Hey everyone, thank you so much for joining my CICD AppSec Survival Guide and for joining us at TechFairLIVE. I'm super excited to be presenting here. My name is Tiffany Jachja. I'm a technical evangelist at Harness, where we help people with their CICD and their software delivery. So this session is really near and dear to my heart because I think that in a lot of ways we can do better for our applications through CI/CD. So I actually wanted to walk through some of the aspects of application security. And if we don't have enough time for any questions or you still have any questions, you can reach out to me anywhere. I'll have my contact information at the end of this session. But I just want to get started and share this content. So I want to start off by saying that today, our most popular and our largest software applications are built on open source software. And more than 4,000 security vulnerabilities are discovered in open source projects and libraries in a year. And so actually code vulnerabilities and source code and even open source vulnerabilities, they can pretty much come from anywhere, not just the code that our security teams or our application developer teams introduce. And so these kind of vulnerabilities can come from anywhere, and they actually impact quite a bit of the industry today. So you can see here, based on a couple of different studies, that the cost of software failures today is just a lot more than it used to be in the past. We can actually impact billions of customers, and one vulnerability can create a chain reaction for vulnerabilities for your customers and their customers, and so on and so forth. And in 2017, there were over 600 cases of software failures that were found, and the majority of them were caused by, I think, software configurations, misconfigurations, at least the vulnerabilities that the survey was looking at. And what happened was it impacted over 3.6 billion people and costs a total of $1.7 trillion in financial losses. And so today, in order to correct a data breach or some type of malicious code, actually costs about $4 million per data breach. And so the question might come up, well, why use CI/CD pipelines in the first place? And I think that understanding or that question comes from a lot of methodologies in DevOps, where we want to automate and enable the continuous delivery of software and software value. And so, as you can see here, in fact, the cost of recovering from vulnerabilities dramatically increases the further down in the process that we go. So, in the design phase, right, fixing or discovering vulnerabilities or even, planning ahead of them doesn't cost you anything, right? Because you haven't really done that much work up front. You're still discussing architecture, you're still discussing design, you're still discussing what tools you want to use, what solutions you want to use, the runtimes, et cetera, et cetera. But then once you go into development and you have your team working, right, and you're integrating code slowly, you're building, you're testing, changes or vulnerabilities that you detect are a little bit more difficult to adjust, right? Because, well, maybe fixing one feature will impact another feature that someone else is working on, and so on and so forth. And then once it gets to testing, right, maybe another team takes care of testing. And so when they find out that there's a vulnerability, it actually has to go back to development. Development has to understand the issue. They have to remember what they did in the code, and then they have to go and fix it. And then once you've deployed something, you have it out in production, you have your customers looking at it, actually becomes exponentially, drastically more difficult to recover from those vulnerabilities because, well, now this application belongs to someone else. It's impacted them. It has to go back down this chain. Everybody is pretty much involved at this point, security, operations, DevOps teams, your developers are even involved, right? Because they want to understand what exactly happened and how do we recover from this. And so the idea in DevOps is that we're shifting a lot of these discoveries to the left. Instead of finding these much later down the process, we want to see if we can't eliminate some of the vulnerabilities as early as possible while they're still cheap and before they cause any negative impacts on our business. And so that's what this session is about. It's about a guide for securing your applications. So I actually want to start by going over some basic definitions of CI/CD, and then we'll discuss a little bit more about the principles behind application security, and then we'll go into the actual practices and tooling. And I want to break it down per uh, life cycle or per phase that you kind of go through when you're working with applications. And this will hopefully give people a better understanding about how they can begin to start securing their applications and building practices and tooling that work for them. Because again, it's always different for every organization. It's different for other teams. The important part is that we can achieve these outcomes. So let's just get started with continuous integration and continuous delivery. It's also called CI/CD, and we primarily introduce or enable CI/CD through what are called pipelines. Pipelines can be scripted. They can be software services that basically take our code, our ideas, our code commits, and they take that code and they package it up and bring it across different phases, right? Whether it's a test phase or a deployment phase, whatever it happens to be, we take this code artifact across different phases into production, into the hands of the customer. And so a really basic pipeline will take our code commit through a build process, a test process, a deploy, and then allow people to do additional testing if they need to, right, in an actual environment or similar to production like environment, and then deploy it. And so often people will talk about CI/CD and kind of think about these things as a single thing, or maybe just a portion of what it actually is. And so I want to break down the different components of CI/CD by talking about continuous integration and continuous delivery. So in continuous integration, we're taking a code commit, right? And then we're building it. And so people will often use different continuous integration servers to do this, right? There's GitHub Actions, there's Jenkins, there's Circle CI, there's TeamCity. And so there's a lot of solutions out there that will take your code, build it based on what application runtime you're using. So if it's a Java application, it'll use Maven or Gradle to build the application. If it's Python, if it's JavaScript, right? There are different builders. It'll package that code, make sure that it compiles if the runtime is compiled. It'll make sure that everything is running correctly. And if it doesn't, right, we'll know ahead. We'll know. We'll know the CI pipeline will fail, and the developer will know that their application, their version of the code that they had committed is not up to par, and it doesn't work. So they can try again. But the continuous integration, it builds, it runs unit tests. It also packages it up into an artifact, right? Whether that's a container image or a jar file or a WAR file, whatever it happens to be. It's this executable that we can put on another machine and run, right? And so this produces an artifact. And this artifact, we can scan it. We can do a bunch of security like things for it, right? But we essentially have this artifact that has some new code. It's packaged up to the best of this process. They think that it's ready to be deployed. And so in continuous delivery, we actually have to deal with, well, what infrastructure, what environment does this get deployed to, right? And how do we want to do it? And how do we want to manage the change? And when we do have it running, how do we want to verify it and make sure things are good, right? And we get to pick when we want to deliver this object or this artifact to the customers. In continuous deployment, which you'll hear about, it's automatic. It goes straight into production. But in continuous delivery, it's a subset of continuous deployment. They're similar. But in continuous delivery, we really want to be thinking about, well, what are our target environments? Is this in the cloud? Is this in a hybrid environment? Where does it live, right? And we want to be able to automate that process as well. So once we know whatever environment we happen to be in, we can deploy this application in whatever architecture you may have. Maybe you're in serverless, maybe you have microservices, whatever it looks like, monolith, web application, whatever it looks like, we'll deploy it and we have it. And so when we talk about continuous delivery or DevOps or software delivery in these modern days where we're really trying to encourage this and make it faster, we're really talking about the ability to get changes of all kinds, whether it's for an application or it's for our infrastructure. We want to get these changes into our hands, in the hands of a customer, safely, quickly, and sustainably. So you want to be able to do this repeatedly, right? And you want to get the same results with quality, with safety, right? Safety, reliability, and you want to be able to do this quickly, because the quicker we can do things, the more often we can deliver value and achieve our outcomes. So the goal when we want to target this specifically, in order to succeed, we really do need to increase our overall visibility into this process, right? Because if, for example, dev teams only know about the continuous integration aspect, they'll think, well, we're done. It's reached the hands of the customer, but it hasn't really actually, and it doesn't until it actually reaches production. And that's kind of how you want to measure success, right? And we want to think about this as well in terms of, well, how are we managing our pipelines? How are we managing custom scripts? What happens if the person who deploys is out that day? Is there still the ability or the control for developers to understand their deployments or what's going on in terms of delivery? And then there's this like extra part of it where we talk about secrets management and security and compliance. And that's all a really big part of continuous delivery. And so there's a lot of aspects to unpack around continuous delivery and continuous integration. There's also a lot of solutions, right? Whether you script the solution or you decide to use open source solution or a platform or a cloud service to do a lot of these aspects or capabilities. There's a lot to unpack here, but I just want to give a better understanding of what is continuous integration, what is continuous delivery, and how can I begin to understand some of these aspects so that I can think about security, especially if it is a responsibility for everybody on the team, like it should be. So let's get to this final part of the presentation about the actual survival guide, the guide to application security. I just want to say that for a lot of people, they don't really realize that there's sensitive information no matter where they are in the software development lifecycle. For example, even in our Git repositories, there's often plain text secrets or sensitive information that's in our Git repositories. So for example, for the SolarWinds hack, that was how SolarWinds was compromised, was because they had left a secret in plain text, which allowed malicious hackers to inject code and allow that malicious code to be packaged in a CI workflow. And so while it was packaged and then it was shipped out and delivered to the hands of customers, that's essentially how the hack occurred. And so you anywhere where you have sensitive information, it's going to be a potential vulnerability area for vulnerability in this sense, right? And so you kind of want to think about these things and what tools are allowing you to really secure your applications, because whether it's in Git or it's with your actual servers that aren't being protected, maybe you have a default password in there and that's the reason why you're going to get compromised. You kind of have to look at the entire ecosystem before you can really ensure that you're securing your applications correctly. And so that's why I wanted to break it down per phase, because I think otherwise it's going to be really difficult. And I don't want to just throw a bunch of practices at you and say like, oh, you got to do all of these. You focused on the particular phases that you can focus on, the ones that you own, the ones that really do need the help, or maybe they're in a spot where they can make a lot of changes and they want to do these things. And so they're going to preemptively do it here. So kind of pick and choose where you want to start. There's a lot of really great places. And so this first phase that I want to talk about is the build phase, right? We've coded, we've made the change, we've committed that code, and now we want to build it, right? And so when we're building it, this is where we're checking dependencies, right? This is where we're packaging up everything, making sure that if we have external libraries or third-party libraries or even internal libraries that we're leveraging, that they're involved, that they're included in our packaged code, right? And so it's actually a really great place to do things like static code analysis, dependency checks. And the analysis reports will give you like general security vulnerabilities or potential security vulnerabilities that you can have based off of source code. So maybe the way you coded something, it detects that you have something in plain text, right? It'll be able to detect that. You can also do things for your GitHub repository using different command line tools to ensure that when you go to commit code or push code, that it gets checked for any secrets or any sensitive information. So maybe, you need a key to access an environment and that's hard coded and maybe instead of doing a git ignore where you don't want to push that file in, you push that file in and it has all the sensitive information, right? So there are different tools that can help with that. There are also scanners after you've built the package, the code and packaged it. So you can have like a container scanner or a runtime scanner that will just also scan for security hacks. So there's a lot of open source solutions, and I really enjoy the open source ones because they're vetted by people in the industry. They're vetted by security experts, right? It's the same thing as RSA encryption that was released by the NSA because they wanted to challenge people to find any security vulnerabilities that could be out there, and now we use it as a standard. So it's just that kind of stuff where you can kind of depend on it because that it's been vetted by the community. And so I really encourage looking at some of the popular solutions over some of the ones where you maybe haven't heard of them before. Okay, the second phase that I want to cover is this test phase, right? This is where we package the code. And so now we can run unit tests and we can run testing suites, right? If we have testing suites. And the important part here is that we look at our code as a white box and a black box. So you actually want to really go in to your application code and check, do I have the proper code coverage that I need to have? If I don't, I need to go in and make sure that I'm testing specific functions, especially important ones. And then white box testing says I don't know what the code implementation actually looks like, but I actually still want to do testing in that sense. And in pre-production environments, you actually want to do, once you've deployed it, you actually want to do some integration tests because this is how two parts will work together. And, if you have any authentication or authorization logic in your application code, you want to ensure that it works between two pieces and that it works the way that you expect it to, just in case that there's something like something going on that you didn't expect. And you really want to be able to do it from the standpoint of, well, yes, we're ensuring code quality, but we're also ensuring security because it works the way that we expect things to. And then this third phase is about delivering, right? So now we have this artifact, and now we just need to deal with our infrastructure, right? We need to provision it, configure it, and then set this kind of environment where we can deliver our applications onto it. And so one thing to consider is that when you are delivering that. Maybe depending on your industry, that you have some kind of change approval process, whether it's through ticketing or through a manual check or a change approval board. Just this idea that someone or there's a person that's going to review some of these changes and ensure that it is exactly the way that they want it to, or works the way that they want it to. And this could be like a team lead. This could be a rotational thing. It could be a board of people. It really depends on your industry, if it makes sense, right? Second thing, the second thing around delivering in terms of applications is also things like pen testing. So penetration testing ensures that, if you hit things with load, if you try to break things, that your application actually doesn't crumble. And then there's 2 tips for actually provisioning and dealing with infrastructure that I want to give. And it's testing your configurations, right? Have some way to verify that your infrastructure is up to date, that there's no vulnerabilities in any of the libraries or services that it runs. So if there was any patches, if you're running things like Nginx, right, that could be really dangerous in terms of actually getting like that service or that node or that infrastructure targeted by any hackers. So one great practice is infrastructure as code for that one. And I really recommend that, is being able to just understand and have a record for what your infrastructure state is, right? If you don't know if someone upgraded it or is doing maintenance on an infrastructure on a particular computer or node, then you can actually have issues where, well, it just gets ignored or it just gets forgotten. And that's actually how historically many of our vulnerabilities have happened in the past. All right, so this is the last phase that I want to cover. And this one is about, well, what happens now that you're running in production, that you've delivered? What do we do now? The biggest thing that you can do in this kind of area is either control how you deliver, so test in production, um, or come up with a way, and actually, I'll just say and come up with a way to manage incidents. So if there are any issues, how do you want to roll back? How do you want to respond to this? Who do you want to call on if there is an incident, right? And the best way that you can understand an incident and quickly recover from it is to introduce observability, logging, and monitoring in your application. So a lot of times when your application is running, people just don't understand what's going on with the application. There's no logs, there's no monitoring on the application in terms of how much load is it getting, how much, how is it responding, what is its latency. And so there are a couple of metrics that you want to track, right? Depending on your runtime. Maybe you're running in Java and you want to understand, like, what is the heap size? What does my memory look like? How much am I allocating enough space for this? So just being able to understand, like, how your application is functioning is really important. And so these are some things that you can introduce into your process. So with that, I wanted to say thanks so much for everyone listening to some of the practices and tooling that you can introduce into different processes. Again, like, security is everyone's responsibility, even though it feels like certain teams own certain processes. I think there's still a lot of capability and opportunity for people to influence some of the decisions around tooling and process that we want to have, right? I've seen a lot of development teams push for observability, push for monitoring, because they want to better understand their applications. In the past, that wasn't always like that. There was not as much of a culture around it. And I think now, because there's a lot more just solutions out in the space and just people sharing, like, hey, this actually works, people are more willing to do and introduce some of these practices. And I think that's the nature of DevOps and enabling a DevOps lifecycle. So I hope that this session really helped you with that. I know it was a little short, but I hope that it was helpful for you, and that if you have any questions or want to know about the different solutions that are in the space, you can reach out or ask here. I'll be around. But with that, thank you so much for joining the session. I really enjoyed it. I hope to see you all sometime in person.